Ladies and gentlemen, welcome to the July meeting of the Royal Astronomical Society of Canada. We don't say that very often because it's too many syllables. Welcome to the Astronomy Club.
Hey.
Any non-members or new astronomers here tonight? Welcome. Tonight we have a program of, I don't know, about a dozen or so speakers, all talking on different aspects of amateur astronomy. This is what we do usually. We have lots of observations and photographs to look at. Tonight is slightly unusual. August 2009 is the 40th anniversary of the Apollo moon landings. So we have a couple of space talks tonight as well. Table of contents, please. So to start things off, please welcome our favorite lunatic, Brian McClure.
Thanks, Attila. Not sure if I like that, but I think I like that.
It might suit. It's better than Pluton.
Okay, departing from the normal, I'm going to read the presentation tonight. So 40 years ago this month, I think you said August, it's July, right? So 40 years ago this month, on July 16th, 1969, American astronauts Neil Armstrong, Edwin Buzz Aldrin, and Michael Collins strapped a Saturn-V rocket to their backs and submitted to a countdown with history. As the boosters ignited 33 stories below them, the crew of Apollo 11 settled back into their couches for the first stage of an 8-day mission that would capture the imagination of a world. It sure captured mine. I was 16 years old. When the Wright brothers demonstrated manned-controlled powered flight at Kitty Hawk in 1903, the product of the brothers' steadfast vision, amazing inventiveness, and unstilting hard effort was there in the air for a small group of people to witness. 66 years later, Neil, Buzz, and Mike would demonstrate their own journey of courage and determination, but these boys would be flying on the dreams of a U.S. president and a German rocket scientist. Their voyage, witnessed by hundreds of millions, would be kept aloft by the successes and sacrifices of the dozens of brave, capable astronauts who went before them, by thousands of superbly talented support personnel, and by the outstanding commitment of their wives and families. As this great summer of '69 lunar drama played out, Columbia and Eagle sped along an invisible 400,000-kilometer trail blazed by the crews of Apollo 8 and Apollo 10 just a few months earlier. On July 20th, with Collins minding the store in orbit, Armstrong and Aldrin left Columbia and flew their Eagle lander down to the surface of the Sea of Tranquility. So they flew in, they did an orbit around the moon, around the back, and came in from the east this way to their landing site. So we've got a little video here. It's just 4.5 minutes long, and you're going to see a comparison with what you see out their spacecraft window with a lunar chart, so you can follow their progress along the ground. Do you have sound with it as well? Okay.
Altitude 5,200 feet.
Manual attitude control is good.
Roger, copy.
Altitude 4,200.
Houston, you're a go for landing, over.
Roger, understand. Go for landing. 3,000 feet.
Copy.
Alarm. 1201. 1201.
Roger, 1201 alarm. Where go? Same type. Where go?
2,000 feet. 2,000 feet. Into the ag. 47 degrees.
Roger.
37 degrees.
Eagle looking great. Your go.
Altitude 1,600. 1,400 feet, still looking very good.
Roger, 1202. We copy it.
35 degrees. 35 degrees. 750. Coming down to 23. 700 feet, 21 down. 33 degrees. 100 feet down at 19. 540 feet down at 30 and at 15. Okay, 400 feet down at 9. Gate forward. 1050 feet down at 4. 33.5 down. They're pegged on horizontal velocity. 300 feet down, 3.5. 47 forward. Put up. On 1.5 down. 70. Got the shadow up there. 50 down at 2.5. 19 forward. Altitude, velocity, light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 160 feet. 6.5 down. 5.5 down. 9 forward. Good. 20 feet. 100 feet, 3.5 down, 9 forward. 5%. 185. Okay, 75 feet. Car's looking good, down a half. 6 forward.
60 seconds.
Lights on. 6. Down 2.5. Forward. Forward. That's 40 feet, down 2.5. Picking up some dust. 30 feet, 2.5 down. Great shadow. 4 forward. 4 forward. Drift into the right a little. 20, down a half.
30 seconds.
Forward. Good. Okay. Contact light. Okay, engine stop. ACA at a descent. Mode control both auto, descent engine command override off. Engine arm off. Port 13 is in.
We copy you down, Eagle.
Griffin, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
When they landed, they had about 20 seconds of fuel, 20 seconds of landing fuel left, and if they hadn't landed by that point, they would have had to, the automatic abort would have kicked in and it would have shot them back up into orbit to rendezvous with Columbia. Go to the next one here. In the 3 years that followed, of course, 6 more crews would voyage to the moon in what soon became boring routine for the public. It was anything but. While 5 of those missions would land explorers, the crew of Apollo 13, which was the original backup crew for Apollo 11, fought for their very lives to nurse their crippled spaceship back to Earth. Budget cancellations doomed what should have immediately followed the Apollo program, a semi-permanent outpost on the moon. Now instead, the US Congress and others threw their weight and money into an international orbiting Earth space station, along with a ferry fleet of US shuttles and Russian capsules. And to what end? Lofty dreams of adapting to long-duration space travel in preparation for sending people to Mars? Maybe they missed a more productive training ground for the Red Planet right here in our backyard. Time will tell as the US commits to the moon once again within the next decade. Lofty dreams for sure, but better grounded than an orbiting station, I think. The kid in me wants to see Moon City up and running ASAP. But I'll settle for something more modest and achievable, a simple manned outpost. And how can we not? After all, Apollo went to a lot of effort to show us the way. Thank you.
In honor of Brian's retro talk, I have a nice retro door prize. Contributed by Doug Loma. I have 3 little books on the missions of Mercury, Apollo, and Gemini. Published recently, but with photographs in the 1960s. And the winner is last 3 digits, 048. Could you bring up the lights? 048? Ah, very good. Yeah. So I'm just curious, how many people here did not see the 1967 moon landing on television? 67. Not being alive at the time is an adequate excuse?
69.
69. Is that what I said?
Nobody saw 67.
69. Okay. So for those people who didn't get to see it, may I realize it's like I was a young teenager at the time, and yeah, I was absolutely impressed that they landed, but I wasn't surprised at all. It was just a perfectly obvious thing to do. And the subsequent landings just became like, oh yeah, that's what we do. That's what people do, is we go to the moon. And I really thought that I would grow up to become a chemist and be doing lunar rock analysis. And when that didn't happen, I figured, well, eventually there's going to be a cheap bus fare to the moon. I figured, well, okay, that won't happen. So eventually, I figure I'll retire, old folks home on the moon. Eventually, I'll get a trip to the moon because it's just such an obvious thing to do. And that didn't happen. We didn't get the flying cars either. That's what everybody was predicting, flying cars and trips to the moon. Instead, what we got, nobody predicted. We got the computers and the internet. It's not quite as good, but it's still impressive. What we have here is a video from a probe sent by the Japan Space Administration. They flew a 1020p, in other words, high-definition video camera, around the moon for many orbits, took lots of pictures, and then, not to be outdone, they projected all the pictures that they had onto a 3D topographic computer model of the moon with height information. And then they flew an imaginary camera in paths that they couldn't do because there would never be enough propellant on the probe around inside Tycho crater, re-photographing it for us. So this is what it would look like to take, I guess it wouldn't be a helicopter ride because it's like aerodynamic problem, they would lift on their own. This is what it looked like if you took a local touristy tour of Tycho crater. And this is probably going to be as close as to the trip to the moon as that I'll get. Maybe some of the younger people in the audience will get to go there for real and struggle with leaky spacesuits and dust on their air vents and problems like that.
Are these pictures?
This is video taken by a video camera flown around the moon that was then remapped as a computer model.
It doesn't look real.
It is real. It looks like CGI, but it's completely real.
Wow.
I don't believe it's been vertically exaggerated either.
Where do we get it?
I downloaded this from the internet. What you want to Google for is JAXA, J-A-X-A, which is the Japanese Space Administration, and Kaguya, K-A-G-U-Y-A, which is the name of the probe. And apparently they flew a Sony HD Handycam or something. Is that nice? Right. There are other vicarious ways of enjoying the moon if you can't go there. One is to go to space camps and space exhibits, and we have Murray Campbell to tell us about his trip to one such.
Okay, good evening, everyone. I have 3 hours of information, 200 graphics, 5 animations, and only 9.5 minutes to present. Yes, that's right. Chance Encounters along Route 72, or how 400,000 people put 2 men on the moon for 1 day back in July of '69. So that's that. So the question is, why do these 2 people look so impressed? Well, I'll tell you. As I was outside on a business trip, believe it or not. I actually got out of Ottawa. And while traveling down Route 72, not far outside of Huntsville, Alabama, over the interchange where the bridge was, I saw this thing. And I instantly knew it. Instantly, from the depths of my heart, I knew what it is. I started to gyrate, move, budge, pissed off my 2 buddies in the car, so finally we drove up to this place, the Davidson Center for Space Exploration. So, not being on the tour guide route, they made accommodations for me. So, we went up there, it wasn't too bad. So, after we paid up, this is what we got. Saturn, 400 feet above the plains below where the former cotton fields are. Well, they make money there now. And I couldn't believe it. Just to give you a scale, there's Mike, my buddy Mike, my boss. That, you can probably fit everybody in the front row into just one of those rockets. Yeah. So, at the Davidson Center, has one building that does nothing but this. It houses this one unique piece of equipment. It also has a center primary function. It also includes Rocket Park, NASA's Marshall Institute Education Center, and NASA's Space Camp. If you're a kid, go to it. When you enter the doors, you can look up, way up, as Mike is doing, and this is what you see, right from the front doors. So that is just ginormous. And you're able to look at the F1 motors. These things, as you can see, quite heavy detail, lots of little plumbing, gyro markets, little place for the cooling stuff, looking along the side, from the back going forward. See how heavy it is. I couldn't believe how heavy this material is. These nice blue struts are holding all this up, and all the steel in between the first and second stage, I just couldn't believe it. Huge, heavyweight stuff. And a little bit of information for those who are interested. And just in case, look, there we are. Holy moly. That's a lot of plumbing. And that's what we were looking at, the second stage. Just enormous amount of materials. Just looking at that, we just couldn't believe all the little pumps, the gyros goes in there, the other extra tanks, the extra heavy steel ringing that goes around there, plus the fuel pack. And payload section. That was huge. It's larger than this room. There it is. And you know what flew this? That one J1 rocket there. That was it. This one rocket boosted out of low Earth orbit, boosted it to the moon, did its little rendezvous out space, and still lots of more different type of plumbing. Like, what are these guys doing up there? So look, I only had 3 hours to look at the entire place, and I already spent a half an hour just at this point. So I just couldn't believe it. So there's the ring that separates the two halves. And for people who want to look, that's a size comparison. So this thing was actually huge things. So there's the payload section. We just looked at this portion here. This holds all the lunar parts and stuff for the Skylab parts, and the modeling showing it for all the components, and right up to some people who like to go for visits. There we go. The command module, that's that little thing that everybody straps their ass to. There's also the launch escape system, which is that thing right there. Just still little tiny little gizmos that does all the work in the world. As I said, boosts you off, got you around here, up around, does this little thing as was mentioned inside. Just gorgeous. And there I am, lifting up the world. That's a football length from where I am all the way back. A football length. I just couldn't believe this. So a little plaque I pulled off here just to let everybody know, including Attila in case he gets lost here. The 20th, the 14th. Anyways, while they're there, they just spent one day. And there we are. It's a real body and a mock-up. But I was really impressed with these little gizmos. We call them puffers, where I come from. They actually move the stuff, and that's what they use to get off of the very flat Imbrium plane type thing. And they also used it to maneuver the Apollo 13 for its flight back to Earth, and that's what they had to use for their maneuverings. The couple little suits here, plus the lunar rover there, and these are real suits, not mock-ups. I was really impressed. And of course, there's that. And everybody knows what this looks like. We used to have one here. And that there's also very interesting. 5 of the sites. And here we are. On the way out, this is what I found the most fascinating of all the aspects that was in there. This plate, this souvenir was given to Dr. Werner von Braun. It had examples from the V2, the Redstone rocket, the little diodes that I used to use when I was in high school, and a few other things that goes along there. And even this thing for the Saturn-V, a little chip. I couldn't believe how advanced they were, actually, because I was still using this in high school, and back in the 60s they were doing that. So I couldn't believe it. So where did this rocket come from? From that thing. The A4, or the V2 rocket. In addition to that, the rest of the programs. Redstone rocket being right there, and it was the primary one for both the military and the space programs, followed by the Juno, the Gemini for the Juno, the Atlas rockets for the Mercury programs, and somebody by the name of Glenn launched his ass off this thing right there. And if you look very closely, this Atlas here, you might not think it's very big, but it's the exact one we have outside. So that's quite huge in comparison.
The one we waited before is the Redstone. The two first suborbital missions were on to the right.
Yeah,
That one, that's a Redstone.
Well, these are both Redstones.
No, the bottom one's an Atlas. That's what Glenn was on.
That one there. When he went up on later.
The one that we have like out
Yes.
here.
Eventually they went there, but actually the very first one, and the Gemini, and then Gemini, and then eventually the Apollos, and everybody will remember what happened to this buddy when he blew up on the launch pad. But yeah, all of them are there, and there are a lot more. So it was a pretty good space park. But then as I was leaving, came across this puppy, and I walked right into the middle of the space briefing. I couldn't believe it. So here's about 100 little puppies back here, astronauts in waiting, getting a mission brief under this full stack. This is the original fuel cell that was ever produced. And the backward view. The Pathfinder, the second one ever produced. That one's only for a mock-up and training purposes, and later for advertising and programs. And as you can see, the huge size of the solid back boosters there, just absolutely huge. So again, when you see it on television, it appears actually small, but these actually really, really huge. And as the forward slide said, to be 12 again. Go to the space camp when you're 12 years old, strap yourself in, play with the dials, actually learn how to land a lunar module or the shuttle. That was really amazing. So anyways, so if you have 12-year-olds, send them there. And if you want to be 12-year-old, go there. Okay, that's it for me.
In honor of all this space stuff, we've arranged for a lunar challenge that's going to follow up on the Apollo theme. Murray, you're on again.
Again, Tranquility Base. Yes, I am. Yes, so the challenge is Tranquility Base. This site has been set for tonight. If you go outside right now, you'll see rain. But that's what you'll get. So the coordinates over here for the site of Tranquility Base. In this first quarter zone, best viewed, few days, 4 days after the new moon or 4 days after the full. And as of today, or this hour, it indicates your little live Asian in the northern area here. So if you want to see the other side of the moon, that's where you might want to point your scope to. In a close-up zoom, there it is. That's the Tranquility Base area. That's the area of object for tonight. And we move in, and right here we see the indicators to where we want to look. The two craters and the double small craters with coming in points to the way. And right underneath, this is what we're looking for. There's no way to be able to see the actually lunar module or anything like this, but the details in there are quite fascinating. You should be able to get a lot of the detail for this. For reference purposes, you can use the Rockwell map number 35, Viscardi page 267, or the Hatfield map 2F8. Again, the eagle is not that very big. The only thing you'll see up there, of course, is this bottom part. And that's about it. And for purposes of references, I don't think you'll find green grass or trees in the area. Okay, once again, that's the area you want. And the primary image is this RIMA, right down there. But if you want to get into the bigger details, smaller details, you can detail into that. So that's the big challenge. Little challenge is the RIMA, and the harder challenge is the details into the actual site. Okay?
There's also 3 small craters directly in the area named after the 3 astronauts.
In the vicinity of, yes. Yeah. Okay.
Thank you very much, Henry. All right, now for some more general astronomy, please welcome Tim Cole, who's going to give us the regular segment Ottawa skies, which is about what you can observe visually in the next month. Tim?
That's easy. What you can observe visually in the next month is clouds.
Thank you.
You're welcome. And by the way, you cannot see the flag on the landing sites, okay? Yes? Do I need the other? Oh, there we go, the other button. And a pulse, by the way, here's your snazzy word for the day. That's actually a close approach of objects in the sky. An apparent close approach. There you go. There's your useless term that I just found out from digging into the documentation for the new sky tools. So here's an opportunity to actually catch a view of Neptune, since it will be right near a fairly bright planet, namely Jupiter. And it says something, oh, rats. Arrgh. I'm only an engineer, I can't handle this crap. Anyhow, yeah, mu cap, which actually seems like an electronic component, that will seem like a large bright star, but it actually isn't. Where the heck is the forward on this? Oh, it's opposite the back. Okay, there we go. So here we have a little Jupiter. And what a stupid place to put the anyway, never mind. I want mine. Anyhow, never mind. So you'll have Jupiter, and Jupiter, of course, if I need to explain to you how to recognize Jupiter, find another hobby. Neptune, it's easy enough to recognize because you'll see a couple of tiny itty-bitty little stars in there, and the green thingy will not be there. Just like that. The other forward, you twit. Now, Neptune and Jupiter is kind of cool. I've used Starry Night to give you a quick view of where it is going in the sky, so you can really see Jupiter is there moving at a great rate of knots. Well, Neptune is just crawling along nicely. So, and we have our closest approach around the 9th. So if I'm... There we go. There's the closest approach, which happens to be one of the lousier nights to see it because the moon's right nearby. So, yes, don't bother looking that night, or if you do, expect a nice lunar challenge. M4, this has nothing to do really. It's just right now, Scorpius is coming near its high point in the sky. So it's a nice opportunity to get a really nice globular cluster. One that you can actually make out with a decent pair of binoculars if you've got a reasonably decent sky. Even from my rotten little suburban backyard, I can make it out. You really do need binoculars on a tripod, at least I do for my wretched, stinking eyes. And here we go, just a nice little close-up. You can see M4. Am I going to get the laser button or the turn it all off? Oh, laser, oh boy. Look at that. Oh, never mind, sorry. So right next to Antares, so a really nice, easy thing to do, and that is a binocular field of view. This is the Ottawa view, and this is the good sky view. See, I can pull defeat out of the jaws of victory out of the jaws of defeat. Anyway, so here we go. Just that's the other forward. There we go. And here we have a nice little close-up of M4. I kind of like this little one. It's not M13, but it's nice anyway. And another little Kodak moment. Even though Kodak has killed Kodachrome, you can still have a Kodak moment, just with Fujifilm. Never mind, forget it. So here's a crack. You've got Mars. The Pleiades are back again. The Pleiades are back again at a reasonable hour in the morning. Yes, Attila, I'm looking at this stupid thing, but I keep hitting the wrong button anyway. A nice little opportunity for the moon. Mars is going to be really tiny and really wimpy, but what I like about this one is an opportunity to compare Mars in color to Aldebaran, which is kind of fun. Nice view of the moon and Venus, which is always fun in my humble opinion. Am I going to get the right forward? Woohoo, the right forward, oh boy. And you can sit here and see how, laser twice in a row. Yeah, and there's Mars, right underneath the moon where you will not be able to see it, and Venus right underneath the moon where you will be able to see it. What did I do? Oh, there.
That's the last slide.
That's the wrong slide. Oh, there. That was the right slide.
Hold that slide. Thank you, Tim.
Hold that slide.
By the way, if people new to astronomy are out looking at the sky tonight and trying to figure out, is that star I'm looking at Jupiter or not, there's a really easy way to find out.
Yes, use a telescope.
Just phone Tim.
Yeah.
Preferably in the middle of the night.
Yeah.
And then after that, what you do is you take a pair of binoculars and just look at several things in the sky. Get used to what stars look like. The one that looks different is the planet. Even ordinary pair of binoculars, even fairly small 7x35s, planets look different. They look a little blobbier, they look a little creamier. It's hard to say in words, but they look different. And you can discover your own planets.
Yeah, they're noticeably different. Jupiter, even through a small pair of binoculars, you're going to see it's a disk. You're going to see it's flattened, and you're going to see two to four of the moons. So I mean, you can't mistake Jupiter unless you really need another hobby.
Don't forget that the planets generally twinkle much less, if at all, compared to stars.
Yeah, that's the other one, though.
But twinkling is a little hard to see naked eye.
Yeah, it is.
Of course, the last experience is Glenn, but binoculars make it really obvious. And then once you've identified Jupiter, you can call Tim up again and say what a great job.
Yeah, you can call me anytime. My phone's opposite the house from my bedroom.
Right, we're running a little early, so we're gonna skip the break slides. We'd like to go directly to Paul Harrison's outreach report.
Hello. Okay, so normally Mike McGunham would be giving these, but Mike could not be with us tonight, so I'm giving these in his place. There's one outreach event that we don't have a slide for, but I'll quickly mention. That was the Galileo lecture we had at Carleton University on June 6th. For those who came out, we all had an enjoyable presentation. The guest speaker was Dr. Roberto Abraham from the University of Toronto, and had a reasonably good turnout considering we were in tough competition with an extremely gorgeously sunny Saturday afternoon. So enough people decided to spend a day in the lecture hall, and they were rewarded afterwards with some views of the sun with our solar observers who'd kindly donated their time. On June 20th, we had another outreach event, this time in Little Italy. It was the end of the Italian week, and this was an event put on by the Italian-Canadian Youth Formation Center. They're a group that provides Italian language education for a number of young people in the Ottawa area, and they were having their year-end wrap-up, and we kindly invited us to come along and share some of our hobby with them. So we had a good time there. There were 4 of us that came out. If we go to the next, I guess, I can go, there we go. So there were about 100 students. If you include all the parents and guests, we had about 400 people there in a large tent just off of Preston Street. We had a barbecue there. There was music. It was warm, 20 degrees C. Mike has it here as a perfect morning. The only thing that wasn't perfect was the fact that it was cloudy, so we couldn't do any solar observing. But we did have a telescope and binoculars set up. We had a laptop showing the IYA trailer and a number of other videos. Planispheres, that was the first thing these people asked for, planispheres. They got hundreds of them. A lot of other goodies we brought. Part of why they chose to include astronomy as part of their theme is that, of course, International Year of Astronomy celebrates the work of one of the most famous Italian astronomer of all time, Mr. Galileo. And just a couple of pictures from there. You'll probably recognize Richard McDonald there with his normal solar viewer, although the best we could hope for that day was looking at balconies of the apartment buildings across from us. And you notice somebody looking through my pair of binoculars on the right there as well. We have another outreach event coming up actually next week. It's coming up on this quite fast. This is another one focused on young people, 10 to 12-year-olds. It's on Tuesday. The unfortunate thing is it's during the day on Tuesday, so it might be hard for people to volunteer their time, just given the fact that it's a work day. But if you are interested and would like to come out and help out, please let me know. They're hoping to get at least a couple of volunteers out. So if you have any questions, just come see me during the break.
Thank you very much, Paul.
Okay.
And if any of you have not done any public astronomy, I'd like to encourage you to do it for a very simple self-serving reason that it's really incredibly fun and very self-confirming to have some kid look through a telescope and scream, "Oh wow," and then drag their parents over and make them look through the telescope. You don't want to, then have them say, "Oh wow." And then sometimes they go home and get their uncle when they come back to the telescope, kicking and screaming, and they look through the eyepiece and they say, "Oh wow." It's really very satisfying. It kind of legitimizes our inner geekness. Whereas I've had this little social situation, if you tell people at a cocktail party or something that you're an amateur astronomer, they kind of back away and cringe. But here's a circumstance where you can legitimately be an astronomer in public, and the International Year of Astronomy, because they've got such a great PR department, makes it all possible. Right. Next we have an announcement. Rothnick is going to tell us about some new dark sky preserves that have been recently declared.
Some of you are aware of what the RAC does on a national level, might know about dark sky preserves. It's a relatively new program as of the last 10 years. The first one was in north of Toronto in the Muskoka district called the Torrance Barrens. And we just have two new ones that have been dedicated in the last month or so. The first one was in New Brunswick, and you can pronounce that. They call it Coochie. Yeah, that's the word. Yeah, what's it again? Oh, Kuchabubuak, okay. Sounds like a dance, eh? But anyway, that's roughly where it is. And to show you how dark the sky is, it's actually supposed to be darker than it actually looks like here. Now, do I aim it at you or them? Them, there we go. And so here, if you look at it here, this is the area in around here, just barely visible here. There's some light south of it, but I understand from people that have actually visited there, I haven't been there myself, we rely on the designations from paperwork, from the nominators and so on. But that's roughly where it's located. Very, very dark area. Relatively, it has camping inside. There's actually some buildings as well. But it's managed by the Parks Canada, and the Parks Canada have a very strict lighting protocol for all national parks now, or not so much protocol, but guidelines. And they're actually incorporating those as budget and schedule see fit. When they start building things, they know they can't shine lights up. I was the author of it, so I'm quite impressed that they went to the Herculean, that is, they actually accepted everything I proposed. I warned them that I was rather biased, and yet they adopted it anyway. The second one, by the way, Dave Lane, our president, was there to do the dedication about a month ago. And the most recent one was last weekend, and that was in the Bruce Peninsula up here. One last year is in Manitoulin Island at Gordon's Park. At Gordon's Park, they have stargazing, essentially a star party there once or twice every year. In Bruce Peninsula, it's a very large park. It's called the Bruce Peninsula Fathom 5 National Marine Park. So if you like scuba diving, you just walk off the beach and you end up seeing wrecks, I understand. I haven't dived there myself. It's fairly a long drive from Ottawa. Here is Ottawa way up in the upper right-hand corner. And it's about, I guess, took us about 8 hours total to get there. By the way, the Torrance Barren is located up here, north of Toronto. And another earlier one is down here in the bottom left-hand corner at Point Pilet. Now to see what it looks like under dark skies, this is, oops, overshot. There we go. And this shows you the extent of it. You can see there's almost no light. You'll see there's a spark of light right here, and that's the ferry dock. It's got about 10 gigawatts of light, and they're nice full cutoff lights that they've tilted them at 45 degrees. But Parks Canada is working on them, since they're both federal agencies, to see if they can actually aim them the way they were supposed to. They were designed to aim. And you can see up in Manitoulin Island, almost nothing. The entire island is essentially a dark sky sanctuary by agreement or by voluntary agreement from the municipalities on the island. And to give an idea of scale, here's the Torrance Barrens here with Huntsville, and I think Bracebridge there. There is light pollution visible from Toronto and the surrounding areas, but nowhere near as bad as it could have been. And again, it's about 10 years old. It was the flagship for literally the entire world. It was the first permanent dark sky preserve in the world. And then down at Point Pilet, there's a fair bit of sky glow near Point Pilet, but it's really close to urban areas, so you get good outreach for that reason. By the way, this is where my place is, and this is where Fred Lossing Observatory is, and this is where the proposed 1 meter initiative goes up around here. Located up here is Algonquin Park, and you wonder, gee, why isn't Algonquin Park a dark sky preserve? Nobody's nominated it. So if you're interested, or you got a favorite observing site up there, especially associated with a federal or provincial park, please think about nominating it. It will be looked upon with favor since I'm chair of the committee. Okay.
All right, thanks very much.
Thank you. Sorry? That's a hint, yeah. Any questions, by the way?
Yeah, Rob?
Yeah.
The Fathom 5 has a couple of lighthouses. You're not going to turn those off, are you?
We'd like to, but alas, they're actually collimated, so they don't put that much light up into the area. But I suspect if you're right near them, you'll see, we were taking photometric readings of the sky, you'd probably find the undulation of it. The main culprit for a lot of the lighting are actually cell phone towers. And those lights now, with the help of the RASC, there's a collimated, filtered version that are now acceptable to the Department of Transport. And so they put far less light. Instead of a 2,000 watt incandescent, it's a 70 watt high intensity discharge bulb that lasts many more years than a light because they cost $7,000 to replace them. So it's great if they last 3 times longer. And that's why people are using them. So it's better for everybody. Okay.
Okay. Great, thanks very much, Eric. We're going to go on to our observation report section where people get to get up on stage and show us the wonderful astrophotos that they've taken or make up stories about the wonderful visual observations they've made with, of course, without proof. But I think tonight, everybody who is presenting has at least photographed proof things. First up is Rob, and photographs of light pollution around his observatory. Or should I say dark skies around his observatory?
Dark skies, yeah, let's look at it optimistically. One thing that got me into light pollution is, first of all, the erosion of the skies at, first of all, Indian River, at North Mountain Observatory, where the RASC Center, the Ottawa Center's observatory was first located. We ended up moving the observatory to Indian River, which is now called for the Fred Lossing Observatory. A number of years ago, many years ago, it was evident that the skies were eroded even further, and we might have to move the observatory much farther from the city. And instead, we dug our heels in and worked on the municipalities around Ottawa to reduce lighting. So and that's what got me involved with it. Another thing that gets me involved with it is the erosion of skies around my observatory. And this is an example of it, and this is a panorama I produced about a week or so ago. There's about, I think it's 20-second exposures, and I've modified it or adjusted it so it appears on the screen here. It's actually a much darker sky than shown here, but I wanted to show you the silhouette of the horizon. The observatory is located halfway between Ottawa and Kingston, and here's oops, I made a mistake, that's all right. This is the first time I'm using it. Here's Ottawa here, which actually isn't too bad. Right next to it is swamped by Smiths Falls. But Smiths Falls is only about 15 to 20 kilometers away. And in the south, we have Kingston.
You must be really close to Lombardy.
Lombardy, right here. Yep. And so this is south. This is looking north, right over the observatory dome. And Perth is also not very good. It's not as bad as Smiths Falls, but it's still not great. We had a meeting with Smiths Falls many years ago, and they were all in favor. In fact, the mayor said that, all you want us to do is exercise common sense. Well, whereas Perth said there is no problem. Well, it turns out Smiths Falls exercising common sense is getting worse than Perth that didn't want to figure anything was a problem. Of course, near Perth is where Fred Worth has his observatory. Maybe he was a little more connected than I was. Having said that, though, if we move along this a little bit, you can see the southern sky is actually not too bad, though you do start getting an influence of Kingston down here. And again, this has been stretched and so on, so it's nowhere near as neat as it was when I took the picture. Moving over, again, you see a part of Kingston as well. Some of the horizon glow is due to just lights from cottagers. And we're working on that through the conservation authorities and stewardship groups in the Rideau Lakes area. I've already given a number of presentations, and they've been, I think, well received. Within 2 weeks after writing an article and giving a presentation, the lights across the lake were suddenly out, or virtually out. It's mind-blowing, and they're still out, which is surprising. So talking to the authorities and publicizing things in newsletter to really work. Cottagers really want to do the right thing. They just haven't got a clue what that might be. We just got to tell them. Moving over to Perth, Again, it's fairly isolated, so you can still see a lot of stuff not that far away from where the glow of Perth is. And the observatory dome, you can see that's been somewhat distorted due to my inability in patching things together. And the glow from Ottawa and Smiths Falls, they kind of overlap. What's kind of neat is if you got cloud cover at different elevations, one elevation one night, different elevation the other night, you can really separate things out. Low cloud, you see Smiths Falls, and not Ottawa, because Ottawa is well over the horizon. And if you get high cloud, then you see more effect from Ottawa. So it's non-trivial as to what's causing the worst part of light pollution in your area. And then moving over, we got a bit of the glow of Lombardy. It's a hamlet of about a few dozen houses and 7 streetlights. There's almost 1 street light for every 2 houses. Terrible. And but I've been told that the township council will not change lights change the lights to accommodate everybody's interests. I wasn't very diplomatic with that one. And then finally, looking back around the south again, still great skies. We have open houses twice a year, and they're usually advertised in Astronauts. So feel free to respond when these announcements are made. So I better vacate the premises, and I'll see you. If you have questions about these, just see me a little bit afterwards. I'll be outside by the coffee table.
Thank you very much, Rob. So we're going to resume our observations section of the meeting. And first up is Doug George. Behind you.
I'm right here. I'm here. Okay, well this obviously is a Veil Nebula, but perhaps as you've not seen it before. What I did here is I used narrowband filters. The 3 narrowband filters are about 3 nanometers wide, so we just see one spectral line. The first filter is a sulfur 2, which in this picture is represented as red, and I don't know which one's the laser here. Here. Okay, so yeah, you see some funny little things here, a little lacy thing there, and in amongst the middle of the nebula. Sometimes there's some shock fronts out in front. So that's the sulfur 2, and then the green is the hydrogen alpha. So the back end of the shock wave, I guess, is a lot of hydrogen alpha emission. And then the oxygen 3 is the blue. And you see a lot of it on the leading edge of the shock front of the supernova remnant. And if you look close, I don't know if you can see it on this screen here, but there's a thin thing that runs out in front of the main shock front. So you can see that in certain parts of the image as well. So there's all kinds of detail in here. I was really quite surprised when I took the pictures. Just how much detail there was, and I spent quite a bit of time fiddling with the color balance to make it come out so you could see all the different structures and things. So it's really interesting. You can pull out with narrowband filters. So I'm going to keep doing some experiments. Oh, and by the way, this is taken during the full moon because it doesn't really matter when you've got narrowband filters. It doesn't really affect anything. And it was actually taken over 2 nights because, well, this time of the year, night's very short. So it was about 4 hours of imaging, and I had to wait until after midnight because, of course, it had to be high enough in the sky. So I got 2 hours each night, and so there's about a third of that for each of the colors. Thank you. Thank you.
Thank you very much, Doug. Next observer is Paul Commission. Paul likes to speak from the comfort of his chair.
That's right. Now that's UGC. That's the Uppsala General Catalog, and it's a catalog of about 12,000 very dim type of galaxies. This one in particular, they're both that I will show. They're both the challenge objects that Pierre Martin gave us last month. And this particular one is a peculiar galaxy. It's a rather odd shape. This is a 10-minute exposure, 20-second exposure stack. And as it's in Cygnus, I had to wait till about 2 o'clock in the morning to take that. Now the next one is switch the thing to the next one now.
Guys?
Next.
Next slide.
All right, now this is 11,492. By the way, they're both around 13th magnitude. They're quite dim, very difficult to see, but this one, the 23 Cygnus is in the upper left-hand corner and sort of, I could have probably cropped the thing off, but these are the 3Ds, you know, distant, dim, and difficult. So they are, I don't know, is Pierre Martin here tonight? Is he here? We can
Haven't
ask
seen him.
if he really saw them himself, because they're very difficult to see. Tella, you could see them, I think, with your scope.
I'll have to try.
Yeah, I think you could. What you got, a 25-inch?
Yeah.
Yeah, you'll be able to see it.
It's a good medium-sized telescope.
Yeah, well, you'll see. I think you'll see them all right. Okay, thanks.
Thank you, Paul. Next observer is Sanjeev. Welcome.
Okay, thanks. Attila says I have a bit more time today, so I'll give you a bit of context. So I've been up here a couple of times showing photos from my DSLR. I think that was about maybe 3-4 months ago. So, or maybe a couple of months ago as well. But in the last 2 months, I've managed to persuade my wife that I really need a CCD camera. That's need, a real need. So, I've got an ST10 about 2-3 weeks ago. So this, we spent a couple of nights, actually the 2 shortest nights of the year, June 22nd and 23rd. It was Monday night, Tuesday night. This is a shot taken on the Monday night at McLaren Island Campground, which is a few minutes west of Cornwall. It was on my first time at that particular site. It's kind of comparable to FL Low in terms of sky darkness, so like a Mag 6 site. But it's got these washroom lights that stay on all night that are quite unattractive lights. But what's that? Yeah, Pelican, yeah. I guess they have security reasons why they want to keep the washroom lights on at a campground. But anyways, for photography, it wasn't really a big deal. And we were overlooking the water, facing the south, overlooking the St. Lawrence. So it was actually pretty good in that direction. So this is the Trifid Nebula, M20. And I'm sure many of you have seen this. Okay, so this is the Trifid. This part here is the emission nebula part, and this is the reflection nebula part. North is that way. Now, I'm still in my infancy in terms of using the cameras. I've got an issue with my spacing behind my focal reducer, so stars are a little bit kind of blobby looking. But this object it's in Sagittarius. If you look through a telescope visually, what I like to see, I have a Daub, a 14-inch Daub that I use, and this usually in the Daub you'll see this upside down, and this I like to see this cat. There's a cat here, and yeah, these two things are supposed to actually be two separate stars, and they should really be showing up, you know, they show up very brightly in a very sort of as pinpricks in an eyepiece, and they look like the eyes of the cat. So if you're ever looking at the Trifid, like it really kind of stares right out at you, those two little stars. And if you go about 2 degrees south of here, you come to the Lagoon Nebula. So it's a very, very rich area of the sky to look at for things like nebulae. Okay, this is the reason I got the camera was because I was really interested in galaxy clusters, and I wanted something that with a lot of sensitivity. Now, this is not the greatest picture. The last one was 18 minutes worth of exposures, so I haven't got my autoguider working properly, so what I've been doing is just doing unguided shots. So I only combined 1 minute exposures on the last one. This one I combined 90-second exposures, so they're very, very short exposures. So I expect to get better results when I get my equipment working properly. But what you can see here is the Hercules Galaxy Cluster. And this galaxy cluster, this is the following night, we were at Nirvana, and there was some very nasty deer flies and horse flies during the day. But at night, thankfully, it got very cool, and most of the bugs went away. But this galaxy cluster, now we're seeing about just under half a degree of sky. All these big white blobby things are stars, and most of the fuzzy things are galaxies. Now this one is the most distinctive one here. This is NGC 6045. And it's about between a Mag 14 and a Mag 15 galaxy. I don't know if you can see these two over here. There's actually two kind of face-on spirals that are kind of colliding into each other. The nice thing about this cluster is that there's actually a lot of interacting galaxies. And I've actually observed this cluster visually last year at Bristol Provincial Park, and in my 14-inch Dob, and I was able to identify about a dozen members. Now, through the eyepiece, again, you have to use high power for this, but you actually don't see any of this wispiness up here. You'll just kind of see little faint fuzzies, and you can't really see any structure, but you can actually detect them in a moderate-sized scope. But there's dozens of galaxies in here, and the cluster is believed to be about 400 million to 500 million light years away, so you're talking about 500 million light years. Again, this field is just under half a degree wide, and north is that way. I don't know if you can see there's a chain of galaxies over here, and there's another chain over here, and there's some leading out this way too. And that, by the way, was 22 minutes of exposures. This is a half an hour's worth. Now, M51, I know this is not a very great shot of M51, but I wanted to try it. And again, it's 90-second exposures, and it's not very. It's kind of a bit fuzzy because I don't think I have the right distance behind my focal reducer. All these are with an 8-inch telescope. It's an 8-inch fixed telescope. It's a modified Cassegrain that I'm using. This was also at Nirvana, taken around I think 1:30 in the morning maybe. Well, you know about M51, so there you go. My first 3 images.
Thank you very much. Thank you. Question from the audience. Who here didn't understand Sanjeev's reference to Nirvana? Anyone? Okay, what Nirvana is an abandoned airstrip about 15 kilometers north of Bon Echo. It's in the black section of the light pollution map. It's as dark as it gets in North America there, which is why we called it Nirvana, because we thought we went and died and went to heaven. Unfortunately, it's also Nirvana for mosquitoes. Just a warning. Next observer is Bubbles.
This is the challenge object that we were given. This little galaxy right here, if I was imaging it looking for comets, I'd freak out if I saw this thing. It looks exactly like a comet to me. And my field of view from side to side is about 1/5 of a degree. An ordinary telescope would see at least a degree, so it'd be 5 times as big as this. And just out of the field of view here is Delta Cygni, the really bright star. I don't know how you'd ever see it in a scope, but I wish you luck. This is the other challenge object that we had, and the galaxy is magnitude 14 or 12, something like that. The star is magnitude 5. Again, good luck trying to see it. It'd be pretty faint. But it's an interesting galaxy. It really showed up nicely, I think. By the way, I should tell you, the Peter Ceravolo is here tonight, and the last few meetings I've been showing pictures from his proof of concept telescope. So this is actually not my telescope, it's one I borrowed from Peter, and it's working very well. Any errors in these images, Peter wants you to know, are mine, not his. Yeah. Sure. Okay.
Just in the upper right quadrant, there's it's like a dark comma with the tail.
I see it, yeah.
The galaxy, and if you can point out,
Oh, just sorry, I'm worse than Tim. I guess it goes over here, doesn't it? Yeah. Okay, are you talking about this one right here?
Yes.
Yeah?
There's a round blob over to the right of that too. Just over to the just to the right now.
Right there. In here? From my view, I cannot see it.
Okay. Is that a dark nebula there? Does anybody know? Obscuring?
Well, if it is, we'll call it McCullough. Gary, I thought you knew everything. This is my Cocoon Nebula. Exactly. And if I had a nice wide-angle scope, the dark nebula is just fantastic. Goes right through this thing. This thing looks really good because it's in the dark nebula. A couple things about this. This thing is about 15 light years across, and it's about 4,000 light years away. The star in the middle here is blasting this thing apart. It's I think it's in the last stages of its no, this one here is, I'm sorry here. Let me just look it up. Yeah, the bright star is only a few 100,000 years old. That's what was special about it. And so it's extremely young star. And it's blasting this stuff apart. It's illuminating all the gas here that's in the area. The red is hydrogen, and the outside edge is a reflection nebula. And I don't know if you see it in my monitor at home. This area here has kind of a purpley blue tinge to it, which is a kind of a combination of the reflection and emission nebulas.
The Orion Nebula gives that a very similar appearance too, and it's another very young nebula.
Anyway, it's an interesting shot. I take these. I like to collect data, and I don't like to process data, and so it's so much more fun to collect data. So I collect all this data, and then Attila says, do you have any images for me this month? And I say, okay. And then I start like 3 a.m. in the morning. I'm working on these images to send them into Attila. And so I always feel like they're half done. If you talk to astroimagers, they never think an image is finished. It's sort of like a painting. All right. This is the Crescent Nebula. Now, this is, I think you can probably see the Cocoon. This one here is about magnitude 12. I really doubt you can see it because red is hard color to see in this night sky. But it shows.
I've seen that actually with a 20 by 100 binocular.
Okay.
The brightest part using narrowband filters.
Well, I was just going to say, if you're going to do that, you might want to use a filter to try. But it's pretty faint. The middle star right here, which is sort of causing this thing, is a star that's basically at the end of its life and is blasting out all this stuff into the sky, and it's going to probably end its life in a supernova. Okay. By the way, this is about 25 light years across. Give you some idea of the size of it. That's pretty big. Light takes 25 years to go across it, and it's about 5,000 light years away. And again, my field of view is about 1/5 of a degree. This is the bubble. I remember the first time I saw an image of this. Is not a particularly great image, but the first time I saw it, it just blew me away. In here, this star here, I believe, is forming the bubble, and it's about 10 to 20 times the mass of the sun. I'm sorry, and it's blasting out the hot gas, the glowing gas, and it's crashing into the interstellar sort of molecular medium, which is denser than the stuff that's forming the bubble. And you see the shock wave being formed as it does that. Interesting thing. And again, all the glowing stuff is just hydrogen that's been so excited that it glows in red. Again, this is mighty faint. I'm not sure. I don't know if you'd ever pick out the bubble out of the nebula, but Gary? No? Okay.
So the brightest parts are visible in a medium-sized amateur scope, but again, you have a bit
You're
of
talking about these parts here? Just around the stars?
Well, the bright part of the bubble there.
Oh, yeah, a little, yeah.
That brightest portion is visible in a moderate-sized telescope, especially if you use a narrowband filter. And in excellent skies, again with a narrowband, you can also see some of that fainter surrounding hydrogen glow.
I was talking to Paul Commission earlier tonight. Let me go back to this one here. This is 688, NGC 6888. And so I was in the, late at night taking images. I spent an entire night imaging this, and I typed into my go-to scope 6883, and 8 looks like a 3 in the dark. So I got this really boring cluster. Isn't even worth Isn't even worth talking about. All right, July 1st, I was down on the Rideau, on the St. Lawrence River at my buddy's balcony looking over the river, watching the July 1st fireworks, and the moon was just above it. And so I set my camera up, and this is a combination of 4 photographs that I just stacked together, so the fireworks wasn't anywhere near this spectacular. But the moon is great. The moon is actually blown right out. If you know Photoshop, white is 255, and that's 255 across the whole moon. There's no detail on that moon, and because the camera was exposing on the fireworks. And I had a kind of a red theme this month. Everything I did was red, and so I have red fireworks one too, but I didn't dare send it in. All right, now. My good observing buddy, Paul Shepard, who is in the audience tonight, by the way, his granddaughter and daughter made him this cake because it's his birthday. And I think this is just the neatest thing I've ever seen. I don't have anybody who likes me this much. I especially like the rings of Saturn. That is just fantastic, licorice icing, the whole bit. It's just fantastic. All the little stars all over the place. Everything you look at that cake, you see more stuff. Yeah.
Must have been painful to cut it.
Yeah. I don't know if I'd want to eat Jupiter. Anyway, I should just show you. This is Paul and his daughter and his granddaughter and his wife. And Julie, the daughter, and Christine, the granddaughter, are the ones who made the cake. And there's the cake in front of them again. And I had a chance this month to visit with you always hear about the religious right in the United States. I actually got to meet a religious right person who explained to me very carefully how old the Earth was, and that every evidence the Earth was created older was created at the same time, which I thought was kind of a coincidence. But no matter what your religious beliefs are, we know the universe is at least 68 years old.
Thank you very much, Bob. And happy birthday, Paul. And I think I'll have to be amending the observing report section next month to include sketches, astrophotos, decorated cakes, and fruit plates. Next observer, somewhat more traditional, is Rolf Meir.
Okay, this was Jupiter, obviously June 14th, the red spot here. Thing to note about Jupiter is that it's significantly higher above the horizon than it was last year. It's about 30 degrees up now, and last year it hasn't been that high in about 3 years, so last year it was only 22 degrees, so it should be a lot easier to see features on it this year. And another date, a few days later.
Rolf, did you have a shadow transit on the previous image?
No. And there's 4 white spots here, and a tiny little red spot there. And here's another night. Not quite as good, but what's interesting here is that you have Io and its shadow, and they're both about equal distance from the center of the planet. Not the greatest, but I was happy to at least get those two. Remember, last month's challenge was to observe the moons of Jupiter and Saturn as they did different things. So I wasn't able to get any occultations of satellites by each other, but still hoping to see some of that. Okay, let's see what's next. Oh yes, so this is quite amazing. So this is pretty rare. June 15th, ISS actually passed in front of Venus as seen from my house. Now, the thing you got to remember is that, the path where you can see this is only about as big as ISS itself, which is about 100 meters. So the prediction was actually for this to be about 300 meters to the south of my house, So I aimed it with the Venus a little bit decentered because I was expecting it to be a little off-center. So I was quite surprised when it actually went right in front of Venus. So let's have a look at that. Oops, why is that? Okay. I don't know why that hand was there, but okay. So remember, this is slowed down by about a factor of 7. Right. Originally, I captured this at 68 frames per second, and this has been slowed down to 10 frames per second. It would just zoom right by. I had to watch the video. I captured it for about 2 minutes because I thought I had missed it. Linda was watching on the monitor, and I was watching through the finder scope. I didn't see anything at the time, and I was about ready to give up, but I kept watching the video very, very carefully. And finally I did catch it. It was obviously like a 1/5 of a second that it was actually in view there. So I slowed it down, and there it is. You can see it's about the same size as Venus. So.
How did you figure it was going to do that?
Pardon?
How did you figure out it was going to do that?
Oh, well, remember last month when I presented the talk about the predictions for the satellites of Jupiter and Saturn from a site called CalSky. CalSky also gives predictions for the visibility of ISS and other satellites. And it will also tell you when the ISS or other satellites are passing near stars or planets or crossing in front of the sun or the moon. So you can find all this on the internet, and it's predicted. Still a few possibilities for the orbit to shift, and obviously I was expecting it to actually be about here, according to the prediction. So obviously the orbit had shifted a little bit. Okay, isn't that amazing?
How many times did it press?
What?
I'm up to about 50 times now.
It's a really low orbit.
Oh, I see. Oh, yes, I see what you mean.
The Americans can't afford to boost it very high. All right, that's the observation section, but Rolf also has a talk on hardware. So you're still up?
Oh, I'm still up. Still up. Okay, so this is about improving the attachment of cameras to telescopes because it doesn't work very well by itself. And I'll show you what I mean. Okay, so the first thing here, this is attaching a CCD camera to a C14, and specifically it's this Skynix camera. So the problem is with these cameras and with all the tubes and things that you have is that you get these tiny little thumb screws, and in this case there's a series of 4 of them. There's another one back there, and they all have to be super tight. And it's impossible to tighten them with your thumb because it's really painful. And of course, you can't possibly do it in the winter. And even if you could, I'm not sure if you could get it tight enough because of these tiny threads, and it's only going through like an 1/8 of an inch of metal there. So I'm really paranoid about the security of this. And I make it really tight. And one time, this did fall off, and it fell on the ground. So that was terrible. And then you've got a cable on here too that's pulling, and it's dark, and you don't know what the cable is going to get caught on as you're moving things around. So something had to be done, right? And you've got this long weight here, and it's really floppy, and this camera itself is kind of heavy. So and then you've got this Crayford focuser, which is like a real feather touch focuser. But you can't make use of that because if you did, well, just the weight of this would just pull it down, and so you have to tighten it to make sure that it doesn't slip down and everything. So what I did on this one, obviously, you saw it as soon as I put the picture up, was to put this elastic cord on. And it wasn't just a matter of doing that because there's no place to attach it on this particular camera. I don't know how other CCD cameras are. But this one doesn't. It's a completely smooth body, so there's no holes that you can put something through, or there isn't even a 1/4 20 thread. So I had to take one of the 4 screws that hold it together, and they're in the corners here. I had to take it out, and it wasn't long enough, so I had to find another long one that was have the same threads. And I put this bracket on in place and put the thing back together. So I put this bracket on here, and I was able to put the elastic cord in that end. And the other end, again, there's nothing on the telescope that you can put an elastic cord or a spring on. So, you know, there's these two screws here that are meant for shipping, but you can also use them to, you know, keep the mirror from moving around. So I took that off and made another bracket there. So that's it. So so it does several things, right? So it reduces the chance of the whole thing falling off because it's pulling on the telescope. It helps to keep it straight instead of flopping down, and it also allows the focuser to be loosened a little bit because it takes some of the weight off, and you can, you know, make use of some of the nice motion of the focuser. Okay, right. So that's that one. Next is DSLR, and this one happens to be put on a refractor. So it's a little confusing in this picture. Now, typically what I would do, you know, is I would take this strap and wrap it around these knobs and, you know, just make it as secure as possible. I was paranoid about the whole thing falling off. Because again, you know, you've got these tiny thumb screws to hold everything together. But then I made this thing here. Basically, it's so the improvement is in this stuff here that's in this yellow outline. Okay, so here's an exploded view. So you know, these are all the parts that are together, and again, you know, you've got these tiny little thumb screws to hold everything together. So what did we do here? So, okay, so the first thing is where these thumb screws go, I drilled a little hole in the corresponding tube so at least when you tighten this, you know, it's got something to go into, and it's not gonna fall off as easily. And then for this one here, I actually did 4 at 90 degrees to each other. What I like to do is I like to put the camera so that you know, it's perpendicular to north-south, so that north is, when you show the slide, north is either at the top or the bottom or the right or the left, right? Like not off at some funny angle, because it makes it really hard to figure out with the orientation sometimes if you do that. So I put these here, so that guarantees that it's, I measured that carefully, so that guarantees that it's at those 90-degree locations. And then next thing, so I made this other thing here out of scrap aluminum and a brass strip that I found in the basement. And so this here is actually used to clamp it firmly to the telescope or to some stationary part of the telescope. And then to allow some room for focusing, this here, it goes on the 1/4 20 thread that goes into the camera, and there's a slot there so it can move back and forth a little bit. And this all goes together. So this part here goes into the camera, and this ring here goes into this tube, and then this adapter goes into this, and this actually screws onto the telescope. Okay, so that's what it looks like when it's actually on the telescope. So this is actually clamped to the black part, which is part of the telescope, so that's stationary, that doesn't move. This whole part here, when this is clamped solidly, doesn't move. It needs to turn around, of course, so that you can accommodate the different angles. Part that does move is this blue part with the focusing knob. This blue part moves back and forth. And then this 1/4 20 thread that goes on the camera that goes back and forth a little bit too, to allow for adjustment in focusing. So slightly different requirement here because this basically only gets focused once. because it's, it's used for time exposure. It's not the same as the other camera, which is constantly being refocused for the planet. And finally, this is what it looks like together. Here are the various adapters, the tiny little thumb screws, and the quarter 20 bolt in the camera. And it's all solidly clamped to the telescope here. And this is very firm. See, the other problem is when you're taking long exposures is that the tiniest little back and forth movement here will show up as a star trail. And I had that for a little bit. And this is mostly taking care of that. Because you can't just rely on these tubes to hold everything together, because invariably they're just going to move, right? So it's out as far as it can be to be as firm as possible. Ideally, you want something triangular, but this is what I came up with. So that's it. So that's it. The end.
Thanks very much. All right, next we have a Deep Sky Challenge, because it's cool to look at stuff. And besides, we need a Deep Sky Challenge every month to encourage Bob to take more pictures. So the challenge this evening is NGC 5866, which might be M102, depending upon whether or not you believe that Messier or Paul Messier actually observed M102 in the 17 whatevers, or whether or not it was actually a duplicate copy of M101, but that's not the reason why it's a challenge galaxy. This galaxy is also a member of a 3-galaxy cluster spread over about 1 degree, I believe, but that's not the reason why it's a challenge object. This galaxy has 1 trillion solar masses in it. That's approximately 10 times the mass of the Milky Way. That's also not why it's a challenge object. It's a challenge object because there's a very, very thin equatorial dark lane going through this galaxy. It's inclined only about 2 degrees to our line of sight. Most photographs don't show it because photographs tend to be overexposed, or at least tuned for the fainter outer layers of the galaxy, and it's difficult to see visually. So the challenge is, for a small telescope, simply find it. It's a very nice object to look at. If you have a larger instrument, say 16-inch, you've got a chance of detecting the dark lane. Fortunately, the club has a 16-inch telescope, so you can all try this challenge. No excuse, in other words. And for the astrophotographers out there who have a ridiculous advantage over visual astronomers, the challenge here is to try to come up with a image that shows both the faint extent of the galaxy's outer portions and the dark lane. And of course, if you've got a larger telescope, you may have a chance of seeing detail in the dark lane itself, in which case I want you to invite me up to your observatory. You might be able to see, say, something like that. Oh, there is a telescope worth having. Right. I believe Chuck had a comment about the Lunar Challenge.
Yeah, thanks.
Okay. Yeah, we mentioned the two. Where are we here? Just go a second here. I have to look out here. A second.
Yeah, do it one more, Chris, please.
One more.
There we go. Yeah, those two guys there.
Yeah, Attila just gave me a couple of seconds here. Thanks, Attila. I just wanted to comment to give you a little bit of perspective. The 2 craters right beside the Apollo 11, one's Sabin. Brian, do you know what the other one's called? Ritter, yes. When you're looking at the challenge, just take a look at these 2 craters. Now, if you remember, you might remember me as the guy that flies over impact sites and wades through a few of them, and even drags a few members through them, Eric, Ron, and so on. I've explored a few craters, and if you get a chance to look at a map of northern Quebec, right beside Hudson Bay, you'll see a twin crater up there as well. This is an impact from a twin asteroid that impacted there, I'm guessing, over 300 million years ago. But just to give you the perspective, these 2 craters here are almost the exact same size of the twin craters in northern Quebec. So take a look at the atlas, see those 2 craters, then when you're observing that, you get a size perspective of what the craters on the moon look like versus what's here on the planet. And like Attila, I was one of the guys that, man, will I ever get to the moon to explore these craters? Well, believe it or not, there's plenty of craters around here to explore.
Absolutely.
Eric and I just came down from up north, and we have a few more to look at as well. But thanks, Attila.
Thank you, Chuck.
There you go. Oh, this is a new setup, I see. So, I'll be brief. All right, there we go. I'll be brief. So, yes, my name's Roman. I'm a member of this center, and for the last year and a half, I've been studying in Australia. But now, since it's their winter break, I've decided to come back and give a short talk. It's, as you can see, it's called The Colored Moon. But before I begin, or to begin, I need you to cast your minds back to February 2008 and what happened then. That was the sort of unfortunate meeting that was canceled. And I was supposed to give this talk at that meeting, but it was canceled due to weather, so next opportunity was this one. So I'll just start. This is just sort of a more for your information type talk, so nothing terribly scientifically deep about it. All right, so someone shout out the definition of a blue moon. What is the definition of a blue moon? Just second full moon of the month, I hear, and that is incorrect. Traditionally, it is incorrect. What a blue moon is, I found this out very traditionally, interestingly, is the third full moon of a season with 4 full moons. The modern definition of a blue moon, oh, I should probably work these slides. How do I work the slides? Sorry, well, that's a very blue moon. The modern definition of a blue moon comes from a 1946 article by Sky and Telescope magazine, which incorrectly stated that a blue moon was the second full moon in a month. Traditionally, it was like I said, the third full moon in a season with 4 full moons. Now, why that is, I don't know. It was just a bunch of farmers, I guess, deciding to have a bit of fun.
Any farmer in their own?
Well, hey, without them, we wouldn't have most of our astronomy stuff. So, kudos to them. But and that mistake has since propagated. But this got me thinking about something else. What about the situation where there are no full moons in a month? It can only happen in February, and it does happen. It has happened. Last time it happened was February 1999. Next time it will happen is February 2018. So what do you think that's called? Your first instincts will probably be correct. Just someone shout something out. No moon? Well, it actually does have a name. Very good. I heard black moon. That's obviously an eclipse, but it's the closest thing you can find. But there is, again, doing research, you might come across an urban myth that the only month in human history that has never had a full moon in it was February 1865. Now, this is incorrect, as most facts are, it seems. There actually is a cycle to it. I did have a chart with the cycle, but unfortunately, when I went down to Australia, I must have deleted it off my hard drive because I don't have it anymore. But essentially, it goes. The cycle goes in relative terms. 2 short cycles followed by a long cycle, which is approximately double the length of the original 2 cycles. I think it occurs once every 17 years on average. So it goes 17, 17, then 34, 32, something like that. So the only reason I wanted to do this was because just to give you an idea, just some information about the various colors that the moon has. Next slide. And as you can see, those are the phases. You can see the moon, the brilliant moon, isn't just a gray and white and black mass that orbits us. It's an actual vivid, colorful satellite of the Earth. And since it's coming up to the 40th anniversary of the moon landing, someone shout out what were the first words on the moon? I heard it. No, but I heard someone had it right down there. Contact light. Contact light. And who said it? Buzz Aldrin, whose mother's maiden name was Moon and who has the same birthday as me. January 20th. So that was my talk. Just, again, just a little bit of humor. I thought I'd make a nice surprise for everyone. Sorry it wasn't Neil Armstrong or someone more famous, but thanks anyway.
Thank you, Robert.
Greetings. In addition to the 10-minute astronomy news, I'd just like to say that I'm also the telescope loan librarian here at the club. And if you are interested in renting a telescope from the club and you're a member, come see me, send me an email, let me know. I did bring this little beauty here with me tonight to the swap tables, and it's an antique looking for a good home. And if anyone cares to make an offer to me, I don't really want to take it home with me in my car. So see me after the meeting. So, first item up on the news, I just want to do a quick review of what's hot and what people are discovering and what's new in science, I guess. Anybody know how to pronounce that? Enchiladas? Is it? Salty enchiladas. Salty seas of Enceladus, or Enceladus. This is a news story from the Cassini space probe, which is in orbit about Saturn right now. It's been doing some close flybys of the moon Enceladus. And they actually have an instrument on Cassini, which is a dust grain, measures actual dust grains from the rings and particles impinging on the spacecraft. And what they've noticed is that these grains actually seem to have some sodium in them. They have some sort of composition analysis, and they said they have some sodium in them. They contain carbonates. They're slightly alkaline. And what this means is that the grains are actually coming from Enceladus in these big geysers. They've actually seen these plumes of the moon, and these are replenishing the rings of Saturn, the outer ring of Saturn, actually, from this moon. And the fact that they think they found salt in these grains indicates to them that there's an ocean on Enceladus. So here's a cutaway view of what they think Enceladus would look like, and it's a big frozen moon of ice. But you can have tidal heating as this thing goes around the planet Saturn, which could melt the ice and could cause a plume, and potentially there could be a liquid ocean here, which is dissolving salts from the rocky core and then shooting them out into space. But as in any new discovery, there's controversy. Two papers are actually being published in the latest Journal of Nature. One saying that this dust grain analyzers found salt in the grains, and this indicates there's a liquid ocean on Enceladus, which could mean that there could be life. It could be warm enough for life if there's liquid water. The other group, using the big 10-meter Keck telescope, has actually imaged these plumes as they come off and put it in a spectrometer, and they've looked for sodium lines in the plumes, and they couldn't find any. So there are two papers now in Nature with seemingly conflicting results. One says there's no salt in the ice and the vapor plumes coming off of the moon Enceladus. The other one's saying that the ice grains have been tested and they contain salt. So we don't know what the final answer is going to be. Cassini is actually going to schedule to make 2 more close passes to the moon to actually do some more sampling of this, and maybe with better data we'll find out more. But it's really kind of a neat thing, because potentially there could be a liquid ocean on the moon and there could be life on those conditions. Number 2. This is a neat story. This is a long-proposed tool for hunting planets has netted its first catch, a Jupiter-like planet orbiting one of the smallest stars known. The method being used is called astrometry. And basically, it's most of the planets that have been found originally, we've been looking at the motion of stars in the line of sight using Doppler shifts. We're looking at the spectrum of the stars. It shifts back and forth on a spectrometer with respect to a line in a chemical in the lab. So you know that it's moving, and you can make very precise measurements of its velocity along your line of sight. This is looking at measurements perpendicular to our line of sight. So actual motions of the star back and forth as the planet pulls it back and forth. And this is an image of the region. This is the star in question. And as you can see, it's been moving quite quickly across the field of view. The reason for this is that it's very close to us. And it's also a very small star. It's one of the smallest stars known, called VB10. These are actually drawn to scale. Here's our sun. Here's the orbit of Mercury. And here's VB10. And here's the planet that's been discovered about it, which is about 6 times the mass of Jupiter. And its orbit is about the size of Mercury's orbit is in our solar system. And this is the angle of the orbit, greatly enhanced in size, but roughly the size on the sky it is. So what they actually have done is they measured this motion of the star very accurately over the course of 9 or 12 years. So they've been taking measurements on a handful of stars over like the last dozen years. And this one actually, they've analyzed the motions down to the thousandths of an arc second. Just to give you an idea of what they're measuring here, over 9 years, the star is moving roughly 1.5 arc seconds per year across the sky. And because it's so close to us, it's actually got relatively high proper motion. Parallax, caused by the Earth moving back and forth in its orbit, is shifting the star by about 1/6 of an arc second per year. They have to subtract that motion due to the Earth's movement from this to get a smooth baseline motion, and then the remainder that's not smooth is some sort of a harmonic term that they found, and the amplitude of this is 6/1000ths of an arc second. So you can see why this is the first discovery. And it's actually extremely well suited to astrometry because the star and the planet themselves are so well matched in size. The star is also very close to the planet, so the wobble you can see is actually relatively large as a portion of the orbit. So this is an ideal system to actually discover astrometry. And even in an ideal system, you know, it's very close, it's a very small star, it's a very large planet. It's still only 6/1000ths of an arc second. So this isn't going to be something that you're going to be detecting a lot of planets with in the near future, I don't think. But it's really neat because it's such a small star, this is actually a cold Jupiter. And what this means is that there could be rocky planets in closer to this in an analog to our solar system that could be in a life zone. And it also means that there's a good potential that there are a lot more planets out there than we might otherwise think that could potentially have habitable life on them.
What type of star is that?
It's a dim M-class dwarf. No, red. Yes, that's all I wanted to say about this. A couple more. Now we're getting into something big and powerful and with a really cool name. Magnetars. My Magnetar is double parked out front. No. Yeah, it's good. Very topical. So on August 22nd, 2008, NASA's SWIFT satellite, which is a gamma ray detecting satellite, reported multiple blasts of radiation from a rare object known as a magnetar, or soft gamma repeater, which they think is caused by a magnetar. They've done an in-depth study of these eruptions over time. There's a very violent cataclysmic variable gamma ray source. This object was the first of its type discovered in a decade, and is only the 5th confirmed soft gamma repeater. Some sources are extremely active, but others can be quiet for a decade or more. So astronomers think that this means that many more of these objects are out there, but we just haven't seen them yet. Astronomers think that eruptions of these gamma ray repeaters arise from neutron stars, but extremely highly magnetized stars. So you have a star the size of a very large star, many times the size of the sun, that collapses down into a neutron star after it undergoes a supernova, for example. But the magnetic fields are now compressed into an area which is, only a few kilometers across. Now you have a compact core, which is all just neutron matter. And no one really knows what the physics of this neutron matter is. And what they think is happening is the star is having star quakes on the surface, emitting bursts of gamma rays as the shell settles to a different energy level. It's basically like a big nucleus with all the, I know the atomic number would be quite high, I guess. So the magnetic fields on a magnetar would be 100 trillion times stronger than Earth's. A magnetar placed half the moon's distance would wipe the magnetic strips of every credit card on the planet, which is quite neat. This particular one they saw was only about 15,000 light years away, and was only discovered because of its outburst. They actually followed it up, after Swift detected it, they followed it up with the X-ray telescope XMM Newton from European Space Agency, and they watched it as it faded over 5 days from the initial eruption, and they found hundreds of smaller bursts over a period of about 4 months, actually. But 5 days after the initial eruption, an instrument detected X-rays that were beyond the energy range of the X-ray telescope Newton. And it's the first time transient high-energy X-ray emission has been detected during one of these outbursts. So they're going to keep on looking at this, and they're always looking for more, but it's really kind of a neat discovery. The physics, whoops. And my final item of news, dark gamma ray bursts. We know about gamma ray bursts. We think we understand that these are basically gamma rays that come out from the moment of a star exploding in a supernova, and they produce huge amounts of radiation, but they're tightly beamed along the poles of the star, basically, in these narrow beams, and we can see them from billions of light years away because they're so tightly beamed and they have so much energy in them, like great big lighthouses. For more than a decade, astronomers have puzzled over the nature of these so-called dark bursts, which produce gamma rays and X-rays, but when you go and look at the source immediately, you don't see any visible light. Even with the biggest telescopes, there has been no visible afterpart, whereas many of the nearer ones, they've been able to see visible light echoes as the supernova winds down, and often you also see a host galaxy at the position of the gamma ray to show you that this is actually occurring in a star, in a galaxy. So one possible explanation for the dark bursts is they were occurring so far away that their visible light was completely extinguished by redshift. It shifted out of the visible and into the infrared where the telescopes weren't seeing it. So these things, maybe they're way back at the at the origins of the universe. The other possibility is that they're just enshrouded in dust in an anomalously dusty galaxy, and nobody was really sure what was going on. But to be far enough away that you couldn't see them anymore, they'd have to be something like 12.9 billion light years away. So, using the 10-meter Keck in Hawaii, the team were looking for galaxies at the location of known dark gamma ray bursts, and they basically stared at these places. There was 14 burst areas that they were looked at, and for 11 of them, they actually were able to discover a very dim host galaxy that hadn't been picked up before. So what this indicates is that these aren't extremely far away. They're actually just in a relatively dim, dusty galaxy. So they're not near the origins of the universe. And what this actually implies, and there's a couple things it implies. It provides compelling evidence that a large fraction of star formation in the universe is hidden by dust in galaxies that do not appear otherwise dusty. The stars that are causing these gamma ray bursts could be very massive young stars that are exploding, and they're still in the dust clouds where the stars are still forming. So they could be enshrouded in the cocoons from their formation. Another implication is that if gamma ray bursts were frequent 13 billion years ago, less than a billion years after the universe formed, we ought to be detecting large numbers of them, and we aren't. So what it indicates is that the first stars formed at maybe a less frenzied pace than others first thought. So some interesting results, and that brings us to the end of my 10-minute talk in 15 minutes. Thank you.
Thank you very much, Al. That's the program for tonight. Oops. That's the program for tonight, but we still have some entertainment lined up for you.